All right, hello everyone. This is video 3 of me trying to learn the NIM programming language using Google's Gemini 2.5 Flash Experimental while solving problems from projecteuler.net. So we're working on problem 3 today. So let me take a screenshot of this. Go to Excalibur. And start working through this problem. All right, so the prime factors of 1, 3, 1, 9, 5 are 5, 7, 13, and 29. What is the largest prime factor of the number 600, 851, 475, 143? Okay, so just a quick 101. I want black. Quick 101. Prime numbers. So a prime number is just a number that's divisible by 1 and itself. So got prime numbers. Sorry, prime factors. And a factor is just for a number n, if n is divisible by x, then x is a factor. For example, for 10, the factors will be 1. What can divide 10? It will be 2, it will be 5, and 10 itself. Out of this, 2 and 5 are prime factors. For the number 15, it will be 1, 3, 5, and 15. Out of this, 3 and 5 will be prime factors, so forth, so on and so forth. So our job here is to find the largest prime factor of the number 600, 851, 475, 143. I'll just say the number from now on and not repeat every digit. So let's see what we can do to solve this problem. Okay, I draw a line here. So let's brainstorm through this. All right, so for our number, I think what we can do is 1, iterate through from 2 to n, check if the current number is a prime. If it is, add it to a list, and then get the largest number out of the list. List's final number. So that will be how we'll do it. I think that's just a very broad overview. So if we zoom in a little bit, if we zoom in a little bit more, how about this? We will iterate still, go from 2 to n, but then skip all even numbers because those we know cannot be in the prime number. Oh, sorry. Check if it's a prime factor, not just a prime number. So, and here we can define a function is prime. So I think this will be the first time we'll be writing a function in the NIM programming language. And what else do we need? I think we also need to define a list that is extensible. I don't know how to do this in NIM, but we'll figure it out. And how to print the last item from the array if we don't know the size, sorry, from the sequence, array, list, whatever we will be using if we don't know the size of it. Last item, if size unknown. If size is not known. If size not known. And, how to define functions. How to define functions. How to def func. Cool. So let's work through this. All right, so we will do nvim problem 3.nym. All right, so loop through numbers from 2 to n for current number 2 to what was the number? The number was 600-851-47475-143. Okay, so we said we will be skipping even numbers. So for that, we will do if current number mod 2 equals to 0. Oh, here's something else we can learn. How to continue. Okay, so here's Gemini 2.5 Flash. In the nym programming language, how to continue inside a for loop. Please provide some syntax for to do that. Continue. Okay, simple enough. Continue. Elif, and I think it would just be easy if we say var number int, so this is how we define an integer. Let's do that. Number elif number mod current number and is prime. Current number. So we need to, if the current number is divisible, is a factor of number and is prime, we need to take a note of it. Okay, so we need to take a note of it. So in the nym programming language, how do I create an array that can grow in size? And how to specify type int for said array. Array or array-like data structure. Oh, specify. Okay, seek. So we will do define an array or array-like structure for holding prime factors. So I'll do, the syntax is var my dynamic array seek int. So var prime factors seek int. Cool. Is that it? Yep, that looks like it's it. So that'd be prime factors dot add current number. Okay, so define number. Now we need to define a function that returns true if a number is prime, or returns false if a number is not prime. So how do we define a function in the NIM programming language? How would we do that? How do I define a function in the NIM programming language? Okay, proc is the word. My function parameter type return type equals discard. Okay, so I think that means proc is prime value number int return type is bool, I believe, and we're doing for, so the way I'm going to define this function is we'll take a number I and then iterate from 2 up to I, and if I is divisible by, let's say x is the iterated number or the number in iteration, if I is divisible by x, not up to but less than I, if I is divisible by x, then we can just return false and say this isn't prime, otherwise we will return true. So for example, for 5, it iterates from 2 to 3 to 4. Sorry, so it will stop here, but it will go from 2 to 3 to 4, and then 5 is not divisible by 2, 5 is not divisible by 3, and 5 is not divisible by 4, so 5 will have a true return statement and be prime. For something like 6, it will iterate from 2 to 3 to 4 to 5, stop here, and the first time it gets a mod 0, it will return true. It will return false, which is to say 6 is not prime and is a consonant, is a composite number, is a not prime number, not a consonant, composite, math, not English. So, for example, 6 is divisible by 2, and the modulo operator will return 0, so it is not prime, and we should return false. So that's the way I'm going to define this function. So for divide by by in 2, and this is how you go up to a number but don't include it. If number mod divided by equals to 0, return false, return true. So I think our prime number function is fine. I think this is it. Now we've added stuff to, so if number divided by current number, and if current number can divide, if current number can divide number and is prime, we add it to prime factors. So I think the only thing left to do is, what is the last number in prime factors? In Python, you can do a negative index. So for example, if 1 gives you the second number, -1 will give you the last number. So I wonder if nim has something like that. In the nim programming language, is there a way to print to get the last item in a seq? Okay, yes, use index -1. Oh, we can use either this sign or a negative sign. Okay, so echo prime factors. I'm going to go with this, and I think this is it. So nim c problem 3, that compiled just fine. So I'm going to run problem 3, and looks like it might take a second because that was a massive number. All right, so let's wait for it to finish. Or I can just fast forward the video and show you the answer. So according to our program, the answer is 6857. Let's go and check if our answer is correct. So username and password 86881. Largest prime factor 6857. 6857. So answer is 6857. We got that right. Correct answer. Smiley face one more time. And we can move on to problem 4 in video 4. See you there.